In this video, we're going to calculate the first four moments of the sample mean when x is a Bernoulli random variable. And we're also going to calculate the third central moment when x is a Bernoulli. And the reason we're doing this is because I'm going to use this in a video, actually my next video, on approximating functions of the sample mean, moments of functions of the sample mean. But let's start this one. So let's let x be Bernoulli, and the density for that is this. X takes on values 0 and 1, and if we look at the mean, that says stick in x, sum over all possible values, so it's from 0 to 1. And when it's 0, things drop out. When it's 1, this goes away. That's 1, so we're left with p. The expected value of x squared, I'm building up to the sample mean. These are just individual items. Maybe I could just put an I right there. Expected value of x squared is you stick in a squared, sum over all possible values. 0, it drops out. 1 is 1. You get p, that's 0, and it's p. And actually, you can do the same thing for the third and the fourth moment. It's also p, and that makes sense. You know, we know the mean is np, but n is 1, so it's just p. And let's look at the variance. So that's the expected value of x squared minus expected value of quantity squared. Stick in these, and then factor out a p, you get p 1 minus p, and that's it. PQ is the variance. These are well-known quantities. So now let's start evaluating the sample moments of the mean. So here's the first sample moment, and since the mean is the sum of the xi divided by n, the expectation can go in through the summation sign, and each one of these is p, and you're summing a constant n times, so the n cancels and you get p. Okay, so now it starts to get a little more interesting, the second, third, and fourth moments. So here, expected value of x bar squared is, first of all, I want to square each of these terms, and then I'll factor out a 1 over n squared, and then the expectation goes inside it, and so here that's the expected value of xi xj. Now here, when I and j are not the same value, these are independent, and so it's the expectation of this times the expectation of that, which would be p times p squared. But when they're equal, then the expected value of x squared is just p. So we have to evaluate this at different levels, and this becomes much more intriguing by the time we get to the fourth moment. So we have to look at it in two different ways. So we have to look at it when xi is, they're the same. So, and that's what this is. And then we have to look at it when they're different. So it's the double sum when I is not equal to j. So now this is a constant. So this is p. And this is going to be expected value of xi times expected value of xj, which is p times p, which is p squared. But now we have to know how many these are. And here we're adding a constant n times, so it's np. And this one is, since it's the double sum, there's n values here, but we can't have the same value, so there's n minus 1 different values. So it's n times n minus 1, p squared. And then this can simplify to this. You factor out an n and we get this. Now, in the next part of the video, we're going to jump from here to here, okay? And the way we're going to think about it is, here there's two quantities. They're either the same or they're different. And let's assume they're the same. So there's n ways to choose this one, and then there's only one way to choose this, so it's n times 1, which is n. Now, when they're different, there's n ways to choose this quantity, and there's n1 ways to choose this one. And so you get n times n minus p. So we're going to jump from here to here in the next few videos, or the next few calculations. So the variance of x bar is the expected value of, x bar squared minus expected value x bar quantity squared. Plug in this minus the mean squared, reduce it, and you get n q, or pq over n, which is also a pretty known quantity. So now let's look at this one. So we're skipping a few steps here from here to here, but I think it's going to be obvious. Since you have to multiply this times itself 3 times, you can factor out the n cubed, and then we get this. Now there's going to be 3 different cases where each of those x's are the same. So we're taking the expected value of x cubed. 2 are the same and 1 is different. So then it would be the expected value of x squared times expected value of x, or when they're all different. And so we're going to treat those differently. So the way we do it, and I'm going to kind of just show the answer here. First, let's assume they're all the same. So there's n ways to choose the I. Then there's 1 way to match it, 1 way to match it. So it's n times 1 times 1. And the expected value of x cubed is p. So this is that quantity. So now here we have to assume that 2 of them are the same and 1 is different. Okay? So we'll ignore this 3 for a second. So let's, there's n ways to choose this first one. And then if we want something the same, there's 1 way to choose it to match. And then there's n minus 1 ways to choose something different than these 2. And the expected value of x squared times expected value of x is p cubed, but the n times n minus 1. But we could also have, I assume these 2 are equal, but it could be the outer 2. So it's n ways to choose this one. This is different, so there's n minus 1 ways. And this has to match the first one, so there's only 1 way. So again, it's n times n minus 1 times p squared. But we could have said this one was different and these are the same. So it's n ways to choose it, n minus 1 ways to choose this one, then there's 1 way to choose this one to match that. And then you get p cubed. So there's 3 of these. And the way you think about it, we're trying to match 2 of these. So we could match these 2, these 2, these 2, or these 2. So there's 3 ways. For this one, they all have to be different. So the first one, and if they're all different, it's you get p cubed, because it's p times p times p. But there's n ways to choose the first one, and then there's n minus 1 ways to choose the second, n minus 2 ways to choose the third. Okay? So then that can simplify to this, and then that's the answer. So on the fourth, this is a little trickier. So now they could all equal. 2 of them could equal, these 2 equal, these 2 equal, these 2 equal, only one, these are different. So it's like a 2, 1, 1. Or we could have 3 the same and 1 different. We could have 2 and 2 the same, or all 4 different. And those are the scenarios. So the first one, let's look at it where they're all the same. So there's n ways to choose. There's n ways to choose this one, and then for these to match that, there's only 1 way, 1 way, and 1 way. So it's n times the expected value of x to the 4th, which is going to be np. Now this one, there are, if let's assume that 3 are the same and 1 is different. So there's n ways to choose this one, then there's 1 way, 1 way, and then there's n minus 1 ways to choose this one. But the expected value of x cubed times expected value of x is p times p, which is p squared. But to match three of them, you know, you can think of it as leave one out. Leave this one out, then these three match, and that one, this one doesn't. Leave this one out, leave this one out, leave that one out. So there's 4 ways to do, you know, 3 of them equal, and that's where that 4 comes in. So this one, it's sort of 2 and 2. So there, you can pick. There's n ways to choose the first one, and then n, you know, 1 way to choose it to match. There's n minus 1 ways to choose this one. There's 1 way to match that one. So that's where the n and n minus 1 and then p squared comes into play. But how many ways are there here? Well, if there's 4 and you kind of pick 2 at a time, the other 2 match. There's 1, 2, 3, 4, 5, 6. But wait, that's 3. And the reason is this, because we've overcounted them by 2, so we have to take 6 divided by 2. So if these are 1, 1, and then this is 2, 2, that's really the same as if this was 2, 2, and that was 1, 1. And so we've overcounted by 2. Now this one, we assume that 2 of them match, and the other 2 do not match, and they do not match the 2. So there's n ways to choose this one, 1 way to choose that, n minus 1 ways to choose this one, n minus 2 ways to choose that. And that's where these numbers come in, and the p cubed, because there's 3 distinct numbers here. And then there's 6 ways to create that scenario where 2 match and the others don't match. And this one is that none of them match, and so there's n times n minus 1 times n minus 2 times n minus 3 ways to pick unique numbers, and then that's p to the 4th. So to simplify that, we get to this. And we're going to use these big long expressions in the next video, but instead of deriving them, I'm just going to point to them. Another calculation that we're going to use in the next video, and this is the last one for this video, is sort of the third central moment. So the expected value of x minus p, and p is the mean of x. So then if you multiply this out, the cube root of it, and then take the expectation in, this is p, 3 times p, p squared, and this is 3p cubed, and this is minus p cubed. Factor out of p, you get this, then that factors to this. So anyway, that's all I have for today. Hope you enjoyed it. If you did, please like it and subscribe so you don't miss the next one. Thanks, bye.